Okay, so in this video, I'm just basically going to tell you about consistent and inconsistent problems or a system when the system is inconsistent or consistent. So if a system is inconsistent, that means it has no solutions, and if a system is consistent, that means that you either have one or infinitely many solutions. So how do you know when you have no solutions and then no solutions, or either you have like one solution and solution, or infinitely many solutions, infinite solutions? And then one solution, you can either call it a unique solution because it's only one solution when you have that. So you technically, you can see that this is for a three linear equation system. It's a three linear equation system. So whatever you do is you have to make this to be zeros. You have three equations, write them in augmented matrix form, and then simplify such that you get zeros here and here. And then after that, you'll remain with these values here. They can be terms. M can be anything, and N can also be anything. So in order to get no solution, when you simplify that, when you obtain zeros here and you look at this two here, when you get no solutions, it's when M equals 0 and N is not equals to 0. So that's why you get no solution. So that's where it becomes inconsistent for this one. So, but now, in order to have one solution, is that M is not equals to 0 and N is equals to some constant C, where C is an element of real numbers, some constant C. M is not 0 and N is some constant C. And when you get infinitely many solutions, it's where M equals 0 and N is also equals 0. That's where you'll get infinitely many solutions. So basically, you'll have something like this. You can have any value here, elsewhere, and you get 0, 0 here, and 0 here. And then you get, okay, let me give an example of no solutions at all. If you get no solutions when something is like this, and here the value is not 0, you can pick 1, for example. So that's where we get and no solutions. The system has no solutions. That's when you get something like this. And then when you have one solution, that's where you have like, if you simplify your matrix, you get something like this. And this value is a non-zero value. Let me just say maybe it's 1. And then you get some constant C. It can be any value. Suppose maybe it's 5 or whatever. Then you only have one unique solution. So this one is for a one unique solution. And then if you have like 0, 0, 0, 0, and then you also have 0 after the equal sign there, this one will result in infinitely many solutions. So suppose maybe that you were asked, you simplified your matrix and you get something like this, k squared minus 4, and then 0, let's say k plus 2. So where will the solution have infinitely many solutions? It will have infinitely many solutions if k equals minus 2. That's where you'll have infinitely many. Okay, so the idea, why is k equals minus 2? Remember, to get infinitely many solutions, this must be 0. This must be 0. And when you set k squared minus 4 equals to 0, and then that means that k is either equals plus minus 2. That's what you have. And at the same time, this is equals to 0. That's when you only have k equals minus 2. Where's the intersection? At minus 2 only. Because for this one, you only have minus 2. And then where does the solution have, where does this system have only, okay, no solutions? Where does the system have no solution? If k, for remember, for this one, it's infinitely many solutions. And if you're looking for only one solution, for no solution, that means k equals positive 2. That way here it becomes 0, and on the side you get 4. So it gives us this condition where you have some constant and some constant. I remember I gave you the things here. So if k equals 2, that's where you have no solutions. Thanks for watching. Don't forget to share and subscribe.